Good afternoon. I hope you're well. I hope you're enjoying what appears to be a lovely sunny day again. I'm surprised. I thought it was just clouds throughout the rest of this week. So welcome back. Welcome back to another Technolive. If things sound a little bit different, which they probably will. Oh dear, I just spotted everything going wrong in the background. That's usual. Then, welcome to the Technocamp's office. I'm back in the Technocamp's office for a stream, which is pretty frightening, actually. I'm using new microphone, different monitors, different setup. In fact, this microphone's been playing up a little bit, so apologies if I'm coming across a little bit quiet or a little bit loud. I don't know. It's all new and exciting. But as I said, couple of changes coming into Technolive. Noticeably, things like the background, the animations, maybe even the thumbnails if I get round to it. But that's not going to distract from what we're looking at today, because I've been in a little bit of a robot mood. Mood. I mean, say both apply for the past couple of days, in that I'm just into robots. So I thought we'd take a look at some robots. And I found this really cool website. Just found out of the blue. This is how things usually go with Technolive. I'm just browsing for fun, find a cool website, think, oh, that's interesting. And we're going to take a look at it. And I don't quite know how to use it, but that's part of fun of finding out, isn't it? And it's all about robots. And this is the website. And I'm going to pop a link in chat as well. It is gears.apostriri.com. .sg. It's not the most well designed URL. It's not something nice and simple and memorable, but it's a really decent piece of software because, here's my robot. It's a little bit of an ugly robot. Oh, I zoomed too far in. A robot in a 3D space. And what's more, it gets really interesting. If we go across these tabs along the top, we can program it in blocks using a language called Blockly. We can program it in Python using a language called Python. And of course, there's a simulator. And that's not all. You can do really cool stuff like of course you can save all your programs. Change Python stuff apparently. You can change your robot, which is really cool. So you could go for all sorts of different designs. And you could change the world. And there's a wiki there which has lots of information how to use this stuff. But I don't know how to use any of it. I haven't read the wiki. So you're along with me for the ride of seeing what on earth happens. And I thought what we'd do is we'd start off with... We'd give ourselves a couple of little challenges. So let's start off with a different world. At the moment we're in the grid map. Plain old boring grid map. Let's go to one of the simpler challenges. Let's go to the sumo challenge. Okay, and the aim of this is to knock all the opponents off the ring. And I thought that would give us a nice bit of focus to see what we can do with this. So let's go to blocks. And we'll say when started. Well, in the motion section, if we use move tank, that just sends your robot straight into the path of the enemy. So let's do that. Move tank. And we can change the speed of the left motor and the speed of the right motor. Let's leave it as is for now. Just see how it goes. There our robot goes. Push, 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 push. Oh, and then we fall off as well. Something about the way the robot just spins in midair always makes me laugh. We've fallen quite a long way. Oh yeah, we're going further and further. Anyway, I'm going to hit the restart. Usually I'd expect the play button to turn into stop button, but in this simulator you just click the restart button. And there you are. So, let's go ahead and do the same thing. Let's stop the robot from going off the edge. And there's two ways we can do that. We can measure the distance and say only move forward a certain distance. I don't know what this distance button's doing. It's saying numbers at me. But I'm going to go one better. I notice there's a big red ring around the outside. If we look closely at the robot, you can see there's lots of different sensors on here. There's this gyroscope. This is location. These purple ones are infrared. And here we've got a color sensor. And it's pointing down. So I thought, let's make that a good... Oh, my apologies. The stream rate is complaining at me. Stream rate, bit rate, whatever. The stream's complaining at me, as is usual. I hope it's still going. To be honest, it's all been a disaster today. Different microphone, different topic. I was meant to do something else. Oh, all gone wrong. But let's just carry on and hope it works. But we're going to go back to blocks. And we are going to set the motors moving. But after we've told the motors to move, after we've told the motors to move, we're then going to check constantly whether or not we are touching red, or we sense red. And for that, we'll need something that can do something constantly. And for that, we'll need a loop. And the best loop for doing something constantly is repeat while true. Because it does what it says on the tin. It repeats while true. Now, the true is a word. That's always true. The word true is true. So we're saying, whilst the word true is true, carry on doing things. So whenever you have a repeat while true, it means do it forever, basically. And we're going to say, forever, check the floor. We need to ask if the floor is red. And the keyword there, of course, is an if, which is over in logic. Let's go for... We'll just do the top one for now. As I said, this language is Blockly. Blockly was developed by Google and kind of abandoned, but Blockly is never my favourite. It's all like messy scratch. I think that sums it up nicely. Sorry, I was just checking. Computers today, just complaining at me left, right and centre. I was just checking something in the background, but oh, my word. But what we're going to do is we're going to check if the colour sensor is picking up a colour. And for that, of course, we're going to need to go to the sensors page. And here we can say colour sensor. Well, that's going to be the only one that deals with the colour sensor, so we'll need that one. But the colour sensor can sense lots of different things. It can sense light intensity, which is how bright something is. Or we could check colour, or colour name, or red, or green, or blue, or... Oh my goodness, what's going on outside? Okay, that was one problem with coming back to the university to do these streams. I forget that everyone else has come back as well. It's just lots of noise everywhere. My apologies. Let's go colour name. Colour name is quite a useful one because it just gives you the name of the color. You don't have to work out any numbers or any values. You could just leave it as is, which is quite a nice feature. So, I'm going to go color name. I'm going to leave it on port auto because that selects the right one automatically, which is nice and useful. But we're going to say if the color sensor on port auto... Oh, I've just spotted something. A mistake. Because this makes no sense. If color sensor, color name on port auto, well, if what? How do we know how much the color sensor is? Even though this clips in nicely, this won't work, which is another reason I'm not so keen on Blockly. What we have to do is we have to actually compare this with something. And for that we go to logic, and we can use a equals one. I'm going to use this blank equals one here with just these two jigsaw cutouts. So if color sensor equals something, and now I can put it in the if. So I've definitely got color sensor inside that equals attached to the if. Not complex at all. That's just the way Blockly does it, which, as I said, an annoying way. But if color sensor equals, well, we want to put the word red in here, but we can't click on it. We can't type in that gap here. We need to find a bit of text we can shove in there, and the place to find that is in text, where you can pick up just the speech marks on their own. It's the very top one, and here we can type the word red with a capital R though. When I was doing my testing, I figured out that if you don't have the capital R, it doesn't work. Really annoying. But if color sensor equals red, then what do we do? Well, we need to stop the robot from moving. And we go ahead and do that in motion. Stop moving and hold. And we just plonk that straight in the if. And one last thing we can do before we test it is, instead of the hold, switch from hold, using this little drop down arrow here, to brake. I'm not sure what hold means, but coast means that it slows down on its own. Brake, though, means it actually properly stops the motors from moving, which is what we want, because we want to stop the motors from moving when they try and drive us off a cliff. So let's give this a go. So when started, start moving the motors, then check forever if the color sensor is reading red. If it does, stop moving. Let's give this a go. Moving forward, moving forward. Okay, then it should sense red and stop. Nice. And yeah, it stopped right on the edge there. That's some good action. If you ever want to see what the robot's sensing at any one time, if you click this little leaflet with a plug coming out, it gives you all the sensor data. So it tells you what the color sensor's reading, what red, how much red, how much green, how much blue. It tells you what the ultrasonic sensor is reading, the gyro, the GPS, the pen. Oh, we might get onto that. But there we go. So, I don't know why I went back to that screen, but we've done one part. We've knocked off one of the enemies. We should probably return. I think the easiest way to do this would be to drive back to the center. So let's give this a go. So we stop moving. Okay, when we read the color sensor, we stop moving and brake. We should send the robot backwards. So we can do move tank with left speed and right speed in the motion tab for however many rotations. Okay. And we want to go backwards. So we'll do minus 20. Minus 20. Or do we actually do 20 and 20 and then minus whatever? I don't know. I don't know this software. Let's give it a try. So, I'm trying for minus 10 rotations, hoping that means going backwards. If that doesn't work, though, we'll try with minus speed. Let's see how it works. Okay, reset the simulation, press go. So we go forward. We carry on going forward. We detect red, then we start going backwards. Nice. And we just need to work out how far backwards we need to go. Okay, interesting. Ah! So, it looks like that was intentional. I can confirm for you, though, it was definitely not. It just so happens that minus 10 rotations is just enough to stop before the edge, which is the biggest stroke of luck I've had in a long time. So, interesting. We'll be able to use that fluke to just, well, we'll just be able to use it, which is great. It's great to hear. Yeah, it just stops in the right place. Huh. Of course, if this were a larger map, that wouldn't work. Interesting. So presumably, if going back minus 10 from here takes us right to the edge. If we go forward 5, then we'll be back in the center. Let's give that a go. So motion, move tank with less speed and right speed, and we'll go for 5 rotations this time and see if that gets us anywhere. So we do the forward. I might bump the speeds up a bit actually, because this is quite slow. Backward. Fall asleep a little bit. It's tempting. Okay, we've done the backward, and then we're going forward through the 5, so it should stop us right where we need to. Hey! That's pretty darn perfect. It's also given me a slight dilemma, actually, because now we know the lengths of this arena. We don't really need to use the color sensor. The color sensor was a bit extra, actually. So we could just turn and go forward 5, then backwards 10. I'm going to do that, yeah. So let's do a turn. Now, I've not actually done a turn with this yet, so this will be interesting. So let's try and move steering with direction. Well, what number should I put in there? 90? Let's hope. Let's hope. We'll see. I'm assuming 90 because 90 degrees, but could be entirely wrong. Also, I forgot it's going to do this whole thing again. Oh dear. Forward. Backward. No, I can't sit through that. Let's whap the speed up on all of these. Let's make that 50, 50, 50, 50, 50, 50. Yeah. One thing we should watch out for, though, is once you change the speed of a robot, you can cause all sorts of unwanted behaviour, like we're seeing right here. Oh dear. Oh dear. Well, we've managed to do donuts. At least we got that going for us. Lots of donuts. Okay, I think we'll put a stop to that. So, 50 caused it to go everywhere. I had a suspicion it might. Robots usually, when they're built to do things quickly, don't always behave correct. Direction. Not sure what to put here now. Let's try 1. And speed 20 as well. Let's see. And let's watch the whole thing, because we have to, because that's how we set the speed. Off the cliff. And back we go, very slowly. Maybe we could speed up the backwards journey a little. Just a little. Anything to stave off this boredom. And backwards we go. And hit the edge. And forwards we go. To the middle. And... oh, that was a tiny amount. Okay. So 1, too small. Let's go 45. Why is my robot carrying on? I didn't tell you to do that. Let's watch the whole thing again. Ugh. So yeah, one of the reasons I thought we'd have a look at robots today is, well, A, the thing I wanted to do didn't work, and B, I've been sorting out so many Lego robots. It's unbelievable. I've done 12 kits today, sorting through all the Lego, making sure every kit has the right amount. Oh, I've pressed escape. That was a mistake. And the reason being is I'm looking to use the robots with my Techno Club, because of course the Techno Clubs are back on. It's a little bit late to sign up for them, but keep an eye out on the Technocamp's website, technocamps.com, because we will be releasing the sign-up forms for next term's Techno Club in a couple of weeks. If you're in Wales, feel free to join up to them. We offer Mondays, which are now physical. They're actually physical clubs down in Swansea University. And we've been having some great fun planting some plants over in the physical club. Wednesdays and Fridays clubs are still virtual. So even if you're not down in Swansea, you're not missing out. Anyway. Okay. So our robot doesn't seem to be turning very well. Can we change that to be something else? I'm going to try something interesting. I'm going to try another movement. Actually, I'm going to try a move with a certain number of rotations. But I'm going to have the left speed be minus and the right speed be positive. And we'll go... there's a number you're always meant to remember when rotating stuff with robots. If we go 90 degrees, then the left wheel needs to turn 90? And the right wheel needs to turn right 90. Just the opposite direction. Let's give that a try. I could be mistaken. Actually, instead of watching the whole thing, we'll just test out the bit of code we need before putting it in the whole thing. Ah, so 90 degrees was not enough. Let's go for 180. Ooh, 180 degrees. Ah, no, we should reset every time. 180? Ugh, not enough. See, I was hoping this was just going to be a nice flat number. One that wouldn't mess up. So let's try for 1 rotations. I was hoping not have to work it out, just sort of know it intuitively. 1 rotation, not good enough. 200 degrees? Let's see. At least we got the turning down. Ooh, 230. Let's see if that works. Ooh, just a little bit more. 240? $245. That's the trouble with robots of this design. The motors themselves don't actually tell you how far they've travelled. Instead, they only tell you how far the motor itself has rotated. Which is really annoying. Because you can't just say, turn the robot right 90 degrees. You have to work out how far each individual motor needs to rotate. Which never works out well. But yeah, we've done the right rotation. And all we need to do now is go forward for 5 rotations and go backwards for -10 rotations, and that should knock off the other robots. So we go forward for 5 rotations. Ooh, okay, that's not gonna work. That's messed up our angle. Trouble is, we've got a sort of unflat side. Is there a robot we can use? If I go to robot, select robot, that's got a flat front. No. 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 CageBot maybe? No. Needs a color sensor. Okay, so we can't really find a robot that's going to do that. So maybe we need to actually move back 90 degrees, or -90 degrees. There we are. That might just do it. Yeah, we're actually hitting it flat now. So we went forward 5, then we go backwards 10. Take a very long time to do it. There it goes. And I think we're done with that. We just need to put this code inside this code. And that's a lot simpler than I thought it would be. I thought we'd have to sense every time. Instead, we only sense once, because it just so happens that the length of the arena is 10 rotations, which is a shocking bit of luck, actually. Oh, let's reset that because it didn't quite start perfectly. There we are. Only thing with a simulator is sometimes I find the physics are a little bit wonky. Because sometimes your robot starts perfectly, sometimes it's skew-if. That's gone very skew-if, that has. Ugh. It doesn't make sense because it was working perfectly previously. Let's restart that. And forward we go. Okay, now it's not going skew-if. So yeah, that's the problem with this. The physics engine, you can't really predict what it's going to do. Sometimes it works, sometimes it doesn't. Which is a small problem with this simulator. Oh, and yeah, see, the robot's gone skew-if again. Interesting. Oh, it might have righted itself a bit now. We'll see whether it messes up when it goes to this next section. Oh, you did mess up. You didn't go far enough. Oh, crumbs. I forgot we moved backwards a little bit to rotate the robot. Do we go off the edge? Oh, no. In fact, we just teeter on the edge. Oh, it's going. And off it goes. Into the void. Oh dear. Let's just stop that there. So, I'm pretty much done with this one. We got close enough. You could spend a lot more time making it as accurate as possible, making it really clever and using all sorts of sensor data. But that requires more than the half hour I'm going to put into that. Instead, though, what we are going to go and do is we're going to go to worlds. We're going to select a world. We'll try a different challenge. So we could do line following. That's using the color sensor again. Paintball? It sounds cool, but I wouldn't know what to do or how to do it. Oh. There's a paintball launcher. Oh, and experiments to do as well. Yeah, why not? Let's go for that. If it goes wrong, then that's fine. It's all about playing around, having a bit of fun. So, we're now in the paintball as the target. Well, first things first, I think we need the paintball robot. So let's go robot. Select robot. And let's go paintball. Oh, and it tells us what all the different things are. So A is left wheel, B is right wheel, C is electromagnet, D is motorized arm, and E is paintball launcher. Oh, that's cool as well. It's got a laser finder, so we can actually find how far away the target is. Okay, so if we go Python, we don't want to run any of this, so let's get rid of that. Let's go... How do we trigger the paintball gun? I'd have thought it would be motion or motor, maybe. Text lists, variables, motion. Let's just try run motor on port E at 20%. See if that does it. If not, we can read the documentation. Let's give that a go. Give that a go. Give that a go. So, looks like we're going to have to read the documentation. So, let's go select robot and read the paintball launcher documentation. Oh, and it's on GitHub as well. Paintball launcher. It's challenging build. To operate the launcher, you must first run the motor in reverse. Ah, that'll be pulling the spring back. Yeah, it says there. Port D, 100% -2. Oh, we can say how many degrees as well. Okay. And then forward. Okay. So, if we run motor on port E at 100% for, what was it? -2 rotations. I'm going to use the wait for completion option because that means that the program will wait for the motor to have finished moving before it moves on. If we don't wait for completion, it means everything tries and runs at the same time. So that's something to be aware of. But what we have to do next in motor again is run the motor on port E, 100% again, any forward amount. So let's give that a go. Let's zoom out so we can see it. Do it. Hey! We did it! We made... Yeah, we got half a meter. 60 centimeters. Interesting. Okay, let's do that for... Said we could do it in degrees. Let's do that for -500 degrees. See if that goes any further. Oh, that's less far. What about -1,000 as the tutorial said? -1,000. Okay. Looks like we're only going to get below a meter if we leave the paintball gun like that. So let's try elevating it slightly. Let's try making it go up. For that, I'm going to use motor. And we're going to use run motor on port A at 20% to position. Because I think we can set the position here. And I think it was D for the actual motor part. Let's look. Yeah, D is the motorized arm. So that's the arm that controls how up or down the the paintball gun's facing. So let's try that for 90 degrees. And if I'm correct, that should point straight up. I'm probably not correct, but oh well. Oh, yep. Okay, I wasn't expecting it to be that violent. I was expecting it to move quite gently. So let's move that down to 1%. Let's do 45 degrees. Oh, reset the thing. There we are. It's like... And, where did the paint land? Oh, we got whatever meter that was. 4 and a bit meters. Nice. So I think we now have all we need to start controlling. Controlling? We've already been controlling. What am I talking about? To start some targets. So I'm going to go to select world again. And back in paintball challenge, I'm going to select variable range. Or, yeah, variable range. The target is placed a random distance away from the starting line. Using what you've learned, program your robot to hit the target. Have we missed stuff in the first one? Oh no, these are proper challenges. Ones that I wouldn't know at all. Maybe I'll work on those in my own time. It seems like a really cool... As I said, I'm really into this website. And it seems it's cool if it's got challenges like that. Okay, so the target's over there. Let's run our code to see where we were getting to. So we were going just a bit beyond. So I think we want to keep the same elevation, the same 45 degrees. But we want to take the power down a little bit. So let's only go minus 900 degrees for the second one, for where we're pulling the string back. Oh, I forgot to reset. Reset every time. Can I change the camera as well? Oh. Oh, a little bit less. We need to go even less. Oh, hang on. Is it? Oh, yeah. Minus 800. And fadunk. And oh, nope, not quite. Minus 850. Oh, reset that. Oh, it's reset closer. Ah. Can we get back to where it was? Okay, we'll try that. It's close to where it was. I forgot resetting will actually move the target. I think we just missed that. Let's move the camera up. Oh, that was close. I think we'd hit it had it stayed where it was. Okay. So, is there a formula for, is there a maths formula for working out how far, what the angle and power should be? You know what? I'm genuinely curious. I'm going to quickly Google that in the background. Formula for flight of distance. Let's go for distance of projectiles. Oh, it's really complicated. Oh, it involves trigonometry and letters and cars. Oh, and deltas. Oh, no, I don't like that. Tell you what, I'm going to research that in the background. And if I can find a nice simple formula, I'll let it be known. But if I can't, now we'll just pretend there isn't one. So, yeah, what was next in the challenge? We're going to say we hit that, because it was fine, but it kept resetting. Find the target. Nah, I think it's actually getting a little bit too hard for us now. Yeah, these are advanced ones. Well, let's try a different world. We've got 50 more minutes. Let's see what we've got. So, fire rescue. That means dragging and moving people. That might be a bit tricky. Maze map's always fun. Could play our own version of Rocket League. I think that's just going to be hitting the ball. I don't think that's going to be too much involved in that. Okay, why not? Let's go... Oh, there's so many options. Let's try and go 2-player? Yeah, see if that works. No, it doesn't. I'm just on my own. I still got my paintball gun, though. I was hoping to be able to play against an opponent, but oh well. There's probably something I could set up in here, but yeah, again, I've never used this website before. One thing I did notice, though, if you go to the joystick icon, you can actually control your robot, which is incredibly difficult to do in this manner. That's me using the mouse. Or you can use the keyboard. Small problem with that, though, is the football appears to be solid. I can't move it. Oh. So maybe maybe Football World wasn't the best one to look at. Let's go select world. Let's go maze map. So this is a randomized maze. If you go to the wiki page, I believe it gives you some challenges. You say how big it is and all that. But we're going to go okay. Now what we're going to do is we're going to go to robot. We're going to change it to the maze robot. No, let's go this one. Okay, so we'll go for the Maze Runner robot with the 3 ultrasound sensors. Because what I'm thinking is, the ultrasound sensors tell us distance. If each ultrasound sensor tells us the difference between each one of them, what we do is we just check every single sensor, find the one which has the less distance. That must mean that's the way to go. But we'll need one more sensor for that. Luckily, I believe there's a robot configurator which opens up in a new tab. I think we can add a... We can change this around. So let's select the maze robot again. Let's add... Oh, no, we click on the body, click add. We want to add a ultrasonic sensor. Okay. It's floating up there a bit. Can we drag it? Oh, we can drag it. Oh, that's cool. Okay, how do you rotate? Okay, rotate that. Nope. Keep that one 0. Sorry, I'm just playing around now. I'm having a whale of a time. There we are. We got ultrasound sensors on all 4 corners. We'll put them there as well. Can I move that one? Yes. Can I move that one up maybe? No? Okay. So we got 1 on 2, 3, 4, and 6. Okay, let's go file, save to file. Oh, it wants to save on my computer. Okay, that's annoying. Let's just save there. Let's go back to this one. Let's go robot, load from file. And where's the robot? Maze custom, there we are. Okay. I'm literally just going off the top of my head. Yeah, let's see. Let's see. So, when we're going to start, we're going to say let's make a variable. Go to variable, create variable. This variable is going to be max distance. There we are. And we're going to set max distance to, well, if we go to math, we can pick up a number. Let's set that to 1,000. Because I think the ultrasound sensors, once they get above the number 255, they stop sensing extra distance. So once we got that at that distance, we're going to go through each of the ultrasound sensors and see if their number is smaller than the max distance. And if it is, their number is going to become the new max distance. Let's make another variable first. We'll make it a direction variable. I'm going to set the direction to... We're going to use text for this one. We're going to set that to nothing at the moment. Then let's go logic and if. Because we're going to say if the sensors, ultrasound sensor on port, it was 2, 3, and 4, and 6, wasn't it? So let's go 2. And it's in centimeters. We need to go back to logic to compare it. Let's use this one with the numbers written in already for us. So if the distance of port 2 in centimeters is less than variables, max distance, then we need to set set the direction to where's my robot? Which port is that? I don't know. What did the robot configurator say? So 2 is in front, 3 is on the left, 4 is on the right, 6 is on the back. So we'll do 2 first, which is front. So direction equals text forward. Yeah. So if the ultrasound sensor on the front is reads a value less than 1,000, we set the direction to forward, and we go to variables, and we set, not direction this time, the max distance to the value that the ultrasonic distance sensor has found. And we just repeat this for all 4 directions. So we'll go this one. This is going to be port 3, which I believe was left. And this one needs to change to port 3 as well. Okay, this one, port 4, which I believe was right. So we change this one to port 4 as well. And then duplicate. This one's going to be port 6. And this one's... Oh! I've dropped my mouse and turned it upside down. That's always a fun thing to do. Backwards. It's going to be that as well. So by the end of checking all of these, we'll find out whether or not, which direction we should go. We should somehow output the direction so we can check stuff. Is there a way of outputting a variable? Text. Can we display text? We can print. Let's try print. And what we're going to do is we're going to print, not max distance, we're going to print the direction. Oh, and that should be at very end. Yeah, sorry I've not gone through this in detail. I'm having a whale of a time and I've gotten kind of distracted. But let's see how it goes. So the least distant one is forward. And if we run that again, the least distant one is backwards. If we run that again, it's backwards again. If we run that again, it's forward. Okay, nice. So we got it telling whichever sensor picks up the least. I've realised, though, that's the wrong way around. Because we want to find whichever sensor is the furthest from a wall. So, let's go to max distance. Let's rename that to min distance. Ooh. Distance. Min distance. And let's change all of these to a greater than. Greater than. Greater than. Greater than. And let's go. Oh, and we should change the 1,000 to a 0. There we are. So yeah, now forward is the way to go because it's the one with the most distance. So now we know to go forward. We can say at the end of this, if direction, and then we go to logic for the equals. If direction equals, and let's go to text and put in forward. If direction equals forward, then we move. Yeah. Let's see how that goes. So the direction is right, so we don't start moving. Because if we started moving, we'd crash into the barrier. So let's do a new maze where the right direction to go is forward. And it works. There we go. And of course it's going to crash. But anyway, I'm going to call that an end to the stream. It's been a bit of a disaster stream today. None of the right equipment works. None of the right audio works. You know, noises happen outside. It's boiling hot in here. I can tell you that for sure. But I think we had a nice time anyway. And even if I went a little bit fast, because I got a little bit carried away, for anyone to follow along, now you know that this cool website exists for you to play around with. I thoroughly recommend it. I had an absolute blast with it. So, I've enjoyed myself. I hope you've enjoyed yourself. And I hope you're enjoying the new sounds and structures of Technolive back in the Technocamps website. With all that in mind, I'm going to say good night. As my robot does the last little dance.